Okay, next problem. More of the same. Find the slope of the function's graph at the given point, then find the equation of the tangent line to the graph there, graph both the function and the tangent line. So really the same problem, just a new function. So the slope is going to be, and I'll call it f instead of y, f prime of 8, because that point there means that x equals 8. So we want f prime of 8. And so recall, f prime of x naught is the limit as h goes to 0 of f of x naught plus h minus f of x naught all over h. You do not need to memorize that formula. There will be a formula in the next section that I want you to memorize. So for this particular problem, my slope is going to be f prime of 8, which is going to be the limit as h goes to 0, f of 8 plus h minus f of 8 all over h. And now we just start working this out. First, we find f of 8 plus h. And just remember what that notation means. It means use your formula for f or y in this case. So I changed it to f. Replace the x with whatever's in parentheses. So I'm going to get the square root of 2 times the quantity, 8 plus h. And there is my f of 8 plus h. Then minus f of 8, which is the square root of 2 times 8. So there's f of 8 all over h. And now we're going to just start working it out. And note here, if we substitute h equals 0, we'll get 0 over 0, which is indeterminate. So we need to do whatever algebra we can think of to cancel that h. That's always your end goal, to cancel those h's. So let's first just simplify that guy a little bit. And so that's going to be the square root of 16 plus 2h minus 4 all over h. And what we did before, when we were doing limits back in chapter 2, when we had a square root, we tried to rationalize. So limit as h goes to 0 of the square root of 16 plus 2h minus 4 all over h times the square root of 16 plus 2h plus 4 all over 16 plus 2h plus 4. Remember to rationalize a radical like this. We multiply the numerator and denominator in this of the conjugate of the numerator in this case. Then recall, when I multiply conjugates, I always get first term squared minus second term squared. Always. A plus b times a minus b, the quantity a plus b times the quantity a minus b is a squared minus b squared, always. And on the bottom, I'm not going to do anything except write them side by side, because remember what our end goal here is. Our end goal every single time is to cancel that h. I want to be able to cancel that h. So I want that h kind of free to allow for canceling. If I distribute it through, it won't be as easy to cancel. So I'm going to leave that h there. Keep simplifying. So that's going to be 16 plus 2h minus 16 all over h times the square root of 16 plus 2h plus 4. Notice I get some excellent stuff canceling. 16 minus 16, those guys are gone. And so I'm down to the limit as h goes to 0 of 2h over h times the square root of 16 plus 2h plus 4. And there's my goal. I'll go out just a little bit. Wait for that to go away. And there's my goal. Those h's cancel. And so I have the limit as h goes to 0 of 2. Make that legible. 2 over the square root of 16 plus 2h plus 4. And now I can substitute h equals 0. To get, and I started off writing something wrong. When I get to the point of substituting h equals 0, or whenever I'm doing a limit, and I get to the point of substituting in the value, in this case 0, that's when you drop the limit symbol. So I don't want the limit symbol here. You write the limit symbol all the way along until you get to the point where you're substituting. Then you drop the limit symbol. Now, while I won't take off from missing limit symbols, it is very common that students that drop their limit symbol too soon never do this last step because they have forgotten that h is approaching 0. So they end up just right here and then they stop. So it is really helpful to write that limit symbol all the way along. Then when you get to the point of dropping or get to the point of substituting, then you drop that limit symbol. And so we get 2 over the square root of 16 plus 2 times 0 plus 4, which is 2 over the square root of 16 plus 4, 2/8, 1/4. And so the slope at x equal 8, the slope, let's put it this way, of f of x equal the square root of 2x at x equal 8 is m equal 1/4. So there's the first part that they asked for, the slope. The second thing that they've asked for, the equation of the tangent line at, and it was 8/4. Well, that I can pretty much just write down. Y minus y1 equals m times x minus x1. And so y minus 4 equals 1/4 times x minus 8. And then like I said before, quiz or test time, and if I've just asked for an equation of the tangent line, that's fine, you're done. But in MyLab Math, they're probably going to want it in slope-intercept form. And if you want to check this, you need it slope-intercept form. So going to slope-intercept form, that's going to be 1/4 x minus 2, distributing that 1/4, and add the 4 to both sides, and y equals 1/4 x plus 2. And that's what we hope the answer is. Now we will graph it so we can see that it is for sure. So doing the same thing we did before, if we put it, no, can't see it there. You can sort of see it there. Put in the original function, so I'm going to clear out the old stuff there. And so we've got, there, that's a little better there. I wish I had better stuff. So we want the square root of 2x, and then my tangent line was y equal 1/4 x plus 2. So y equal 0.25x plus 2. Now generally I'm going to tell you not to use decimals because decimals, especially like square root of 3, and you estimate the square root of 3 of 1.71, that's not the same. So generally do not give me decimals, but here 1/4 is square root of 2. Now this is the square root of x, so one's still going to start with zoom 6 and see what we get there. Zoom 6 will usually work. And so there's my curve, and there's a tangent line, and I don't feel really confident about this. But this is about the best we're going to do. If I go to x equal 8, trace 8, it's clear over there, and so we're not getting a great picture, But the problem with this is going to be that the tangent line and the curve itself are so close together that we just can't get the resolution on the graph that we'd like to see. Now we can do a little bit better. I'm going to set my window, instead of going all the way to -10, I'm going to go to -1. Well, actually, I'm going to go -2, just because we can do things by 2. And I'm going to go, we were doing 8, so I'm going to go a little bit farther than 10. Maybe I'll go to 14, and I'll count that off by 2s. And everything was in the first quadrant, really, so I'll go -1. And my point here was 8, 4. Yeah, I'll leave it at 10. And then we'll hit graph, and we'll see what we get. Oh, I should have changed that and gotten rid of the, I'm going to change it again momentarily here. I don't need all that y, negative y-axis. I should have gotten that wrong. No, I didn't change that. -1 to 10 on the y's. And so there's my graph, there's my curve, and there's my tangent line. And the thing is just running too close together to really see much difference. Let's do my window one more time. And this time I'm going to go all the way to 20, and we might start seeing things better. So there's my curve again, going all the way 20. And there's my tangent line, and we do seeing it start to diverge a little bit there. And I'm going to do my window one more time. I don't need to go all the way up to 10. And notice how I'm just kind of guessing on the window as I go along. Let's maybe try just going to 6, see what happens. Then I just keep kind of zooming in on the picture until I get something that I think looks good. And that probably was too low. And so let's try it one more time. 6 was too low. And so maybe 8. And you just keep playing around with it till you get something that you think looks good. There's a curve, there's a tangent line, and now if I do trace 8, notice that that point seems to be kind of right in the middle where the two graphs are running together. And they're running together because they're just so close together we can't have the resolution to make it look good. But that looks reasonable. And so I would feel okay about my answer as opposed to a graph that looked really wrong. Let's say instead of 1/4, I just said 0.5. And so there's a wrong answer, and I graphed the wrong answer, and so there's the curve. And there's a line, and it's not touching the curve at all. And so there's something that's clearly wrong. So the things that look right probably are right. At least you can feel good about it. Things that look wrong are clearly wrong. And that is where we will end this lecture.